Now see, we already discussed path length and displacement. Now see, suppose object or the particle is changing its position with time. Suppose this one is initial position, this one is final position. Okay. Now, one particle move from this initial position to this final position like this. See, this is the motion. And another particle move like this. So, can we say these two motions are same one? No. Means now we have to think about one more physical quantity and that we have to associate with this motion. Here we have to think about how speedily the position is changed. Okay, that is also very important factor in the explanation of motion. And for that, now we have to think about another physical quantity, average velocity and average speed. Now the definition of average velocity, that is displacement upon time interval. Its unit, that is meter per second. So symbolically, average velocity is represented by symbol V with bar on it or this type of triangular bracket. Okay. And displacement, that is change in position, that is x2 minus x1 upon time interval t2 minus t1. So we can write that is delta x by delta t. Okay. So this is the average velocity. Then average speed. So definition of average speed, that is path length upon time interval. That is path length upon time interval. Now see here, path length, that is total distance traveled. Now in previous theory, we discussed this thing, displacement, that may be positive, negative or zero. And therefore, average velocity, that can be also positive, negative or zero. And path length or the distance traveled is always positive. Therefore, average speed is always positive. And when displacement is less than or equal to path length, it implies that average velocity, that can be also less than or equal to average speed. All these things that you have to remember because are very important in problem solving. And now see, when we think about the motion of object or the particle in one dimension or only on one axis, or we say it is on a straight line. So in that particular case, when we take the reference, that is the origin of the Cartesian coordinate system, then if motion of the particle is in positive x direction, then we take its velocity, that is positive. So all the parameters will be considered positive. And in negative direction, all the parameters will be taken negative. Now, if the particle or the object is moving with positive velocity, negative velocity, or we can say if velocity is zero, then which type of x or position versus time graphs will be prepared? Or if we have graphs of x versus t, then what we can say about average velocity? That we have to understand. Now, suppose first think about position versus time graph for the object is moving with positive velocity. and that velocity is constant one. So graph that will be a straight line graph, inclined at some angle with time axis. And now at time t1, the position is x1. At time t2, the position of the object is x2. So here from the graph, if we calculate x2 minus x1 upon t2 minus t1, then that is delta x by delta t. But this delta x by delta t, that is also called slope of the graph. That is called slope of the graph. And here x2 is greater than x1, therefore this slope that will be positive, so average velocity is positive. And when the graph is a straight line, then always remember this thing, its slope will be constant one. Or in other words, we can say here, we can observe this thing from this graph. In the same time interval, the distance covered will be same one. So your average velocity, that will be constant one. Now let's think about this second graph. That is also a straight line graph, but that straight line graph is moving downward from y-axis towards x-axis. Now, again, if we take any 2 points on the graph and then corresponding to time t1, the position x1, and at time t2, if we take the position x2, and then if we calculate average velocity x2 minus x1 upon t2 minus t1. So here x2 is less than x1, so it will be negative. Okay, and here also when the graph is a straight line graph, then slope will be constant one. Slope will be constant one. It implies that we can say the object is moving with constant negative velocity. Means it is moving in negative x direction with constant velocity. Now see here, third graph. The position of the particle is not changing at time t1, at time t2, the position that is same one. And therefore, average velocity that will be equal to 0. So from x versus t graph, you can explain the average velocity also. Now clear to all of you or any doubt in this one?